Hi, I'm Matt Genther, accompanied by Aurelio Bellotti, and this is Hollywood's Guide to Metal Strengthening. There will be 4 methods that we'll be talking about today that restrict dislocation motion. The number one benefit of this is to increase strength. However, this comes at the cost of ductility. And this can be best shown in the following Hollywood clip in which our contestant runs through various obstacles quite slowly.
Lands on the second ball. Cat-like onto the third. Oh! Amazing, wedges himself in. And then, oh, Kieran, I love you. You're my new hero.
The first method we have to increasing strength in metals is to reduce grain size. Metals are made of grains, which can form boundaries at the intersection of various interfaces. These grain boundaries are barriers to slipping. Smaller grains means that we have more barriers to slipping, and more barriers to slipping means that our metal is stronger. This can be seen in the following graph and equation, where d is the diameter of the grains, and sigma y is the yield strength of the metal. In the following Hollywood classic, we can see small objects impeding motion of intruders.
Come up here, you morons! Come and get me! You guys give up, or you're thirsty for more?
The second method we have to improving strength in metals is by alloying, also known as solid solution strengthening. By alloying, we introduce impurities that distort the lattice structure and generate stresses within the metal. These stresses can produce barriers to dislocation motion, as seen in our small impurity picture and our larger impurity picture. In addition, this increases the tensile strength per weight percent of the alloy, as seen in this graph below. In the following Hollywood classic, we will see how alloying produces the strongest metal known to man.
That allow you to...
What about this one?
No, that's just a prototype.
What's it made of?
Vibranium. It's stronger than steel and a third the weight. It's completely vibration absorbent.
How come it's not a standard issue?
That's the rarest metal on Earth. What you're holding there, that's all we've got.
Yes, I think it works.
Another method we use to improve the strength in metals is by cold working, also known as strain hardening. In this method, we increase dislocation density by using plastic deformation techniques, such as forging, rolling, drawing, and extruding. By increasing the amount of dislocations, we therefore improve the strength of the metal. In the following equation, we can see that the change in area divided by the original area times 100 is the percentage of cold work formed on the metal. Sigma T, also known as the tensile stress, is improved as we increase the cold work. This can be seen in the next Hollywood classic, how long this method has been being used.
Thanks, Matt. I'll take it from here for our fourth and final method, precipitation hardening. This method uses heat to form fine precipitates and impurities that resist dislocation motion. There are 4 steps to this method. The first is to heat until the solution is properly formed. The second is to quench until room temperature. The third is to heat to a lower temperature until the metal is properly aged. And the fourth is to cool it back down to room temperature. From this equation, we can see that yield strength is proportional to 1 over the distance between precipitates. In our next Hollywood classic, we can see how precipitation strengthens something more than metal.
Why didn't you write me? Why? It wasn't over for me. I waited for you for 7 years. And now it's too late.
I wrote you 365 letters. I wrote you every day for a year.
You wrote me?
Yes. It wasn't over. It still isn't over.
Next, I'd like to talk about reversing some of the strengthening techniques we had previously mentioned. Grain reduction and cold working are 2 methods that are reversible. Annealing is a heat treatment that is applied to strengthen metals that reduces dislocation density, increases grain size, reduces strength, and increases ductility. In our next Hollywood classic, we see how a heat treatment weakens the most precious of metals.